we learned how to write the symbols for an element. We learned how to write a symbol for a molecule. We also learned how to write a symbol for molecules having 1 atom, 2 atoms, 3 atoms, more than 3 atoms, etc. Now coming to another concept, chemical formula for compounds. You have taken two dissimilar elements and you combined, you got a compound, and now you are asked to write the formula or some representation of the compound. How could you do? For example, you have taken an element called sodium. And you have taken another element called carbonate. Now you combined, you get a new compound. Now how do you write the formula for the compound? To write the formula for the compound, we had to use some rules. The first rule is rule number 1. First, you have to know that what is the atomicity of these elements. Or instead of atomicity, you say what is the valency of the elements. Okay, rule number 1. Valency of sodium is 1. We know that. And valency of carbonate is 2. So first, after knowing these valencies, now rule number 2. Write down those elements with those valencies. Okay, I'm writing like this: Na1, the first one, and CO3, 2. Now rule number 3. When you combine them, interchange the valencies. This valency goes to sodium, this valency goes to carbonate. So it comes like this: Na, the valence is this one, carbonate valence is that one. Now rule number 4, last rule. Write down the compound formula with those valencies taking to subscript. So Na, these 2 go to subscript, become like this 2, and CO3, 1. You can write as it's 1, no need to write, just write CO3. And therefore this becomes the chemical formula for the compound. Now try for another example. I have given first element aluminium, the second element SO4. Now find out what are the valencies of those 2 elements. Aluminium valency is 3, sulfate valency is 2. So I have went to the rule number 2. So aluminium 3 is valency, sulfate is 2. So now next step is what? Interchange the valencies. So write like this: aluminium, sulfate, SO4. Interchange. So its valency become 2, its valency become 3. Now write the compound name. So Al2, SO4, 3. That is the formula for chemical formula for the compound. So try for other chemical compounds also. Okay, so we have learned so many things in this chapter: element, compound, substances, combination of the compounds, combination of the elements. Now how do you find the mass of an element or mass of a compound? Earlier we discussed the law of conservation of mass, that the mass remains constant. Total amount of mass before reaction equal to total amount of mass after reaction. Yes, you are correct. But to check that law, we should know how to find the mass of a particular element and the compound. Then see this thing. This is called atomic mass unit. Different scientists have given different, you can say, proposals to find the mass of a substance. But all those are not agreed by the group of scientists in the world. At last, they understand that different atoms have different types of masses, different elements have different types of masses. So why don't we take a reference, a standard atom or element, and by taking the mass of the element, we can give the mass of the other elements also. So in that course of thinking, they have taken this one, carbon, C612, carbon atom, C612. And what I have done, this carbon atom has nucleon number 12, A equal to 12, nucleon number is 12. That means 6 number of protons, 6 number of neutrons it has. So then they divided the carbon mass, the carbon atom, into 12 equal parts. If this is the carbon atom, then divide into 12 equal parts. First part, second part, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 1, 2, 11, 12. So 12 equal parts they divided the carbon atom. Now they taken one part from that, say one part, any part you take, because each part has same amount of mass. Now if you ask the question, then what is the mass of this part? The quick answer is the mass is having the mass equal to 1/12 of C612 carbon atom. Isn't it? Yes, correct. So if the carbon atom consists of 12 grams of mass, as the mass number is 12 grams of mass, then one part of the carbon atom consists of 1/12 of C612 atom's mass, means 1/12 into 12 grams, so 1 gram. So in that way, they told that you take any atom, that atom mass should equal to mass of 1/12 of carbon atom, and that mass is called atomic mass. So the definition comes like this: mass of any atom is equal to mass of 1/12 of mass of C612 atom. Then this mass is called atomic mass, and it was universally agreed. And atomic mass has a unit, because generally mass is measured in terms of grams. Similarly, the atomic mass is also having some unit, but it is not gram. Of course, you can express in grams, but the original unit is atomic mass unit. In simpler form, you can write AMU, atomic mass unit. Still, they simplify to a symbol U. So atomic mass unit expressed in terms of the symbol U. That is the unit of atomic mass unit. So if you ask what is the atomic mass unit of carbon, and its mass unit or atomic mass unit is 12U. Simply you can say 12 AMU or 12U. If you ask what is the atomic mass unit of oxygen, simply it is 16U. What is atomic mass unit of nitrogen? Now you think you understand. We are taking the mass numbers. So the answer is 14U. So in that way, they made simpler to us to understand the atomic mass of a particular atom. Now I'm going to draw a table where I will show the atom and its atomic mass units of some elements. Now the two rest of elements in periodic table, if you want to know the atomic mass unit, refer the periodic table in chemistry. So element, its atomic mass unit. Let me write down the elements in this table. Hydrogen, carbon, nitrogen, oxygen, sodium, magnesium, aluminium, phosphorus, sulfur, chlorine, potassium, calcium. So these are the some elements I have written on the table. Now let me tell you one simple rule. Generally, atomic mass unit is nothing but it is the U times of mass number. Say carbon, I told 12U. 12 is the mass number and U. So 12U, I given the atomic mass unit of carbon. Similarly, if you want to write quickly this atomic mass unit, you should know the atomic mass number. And generally, mass number is the twice of the atomic number. So all these elements atomic number, if you know, double it gives the mass number, and that mass number into U is the atomic mass. But one caution, it is not true for all the elements. Okay, let me write. So hydrogen 1, so its atomic mass unit is U. Carbon 12, so its mass unit is 12U. Nitrogen 14, 14U, 16U. Sodium is 23. It's changed. Sodium atomic number is 11. So mass number is not 22, it is 23. So some elements will change. Magnesium 24, aluminium 27, phosphorus 31, sulfur 32, see sulfur 16, 32, chlorine 35.5, potassium 39, calcium 40. So chlorine, if you see 35.5, it's a decimal number. Okay, of course you can write 36, but the perfect number if you want to write, you should write with the decimals. So we have learned about atomic mass unit of different atoms. What about the masses of molecules, which is called molecular mass? So how do you represent the molecular mass? It's a very simple mathematical calculation. How many atoms you have in a molecule, you take those atoms and their atomic mass and add them to get molecular mass. Let me give an example. Take a molecule of H2SO4 and you want to know what is the molecular mass of it. You know that hydrogen atomic mass is U, sulfur atomic mass is 32, oxygen atomic mass is 16. So H2 1 into 2 plus sulfur is 32, so 32, only one sulfur atom is there, 32 plus 4 oxygen atoms are there, so oxygen is 16, so 16 into 4. You got it? How I am writing the mathematical calculation, right? So 1 into 2 is 2, 32, 6 into 4 is 64. So how much you got? So 4 plus 2, 6 to 8, 60 plus 9, so the answer is 98U is the molecular mass. So in that way, any molecule you take, if you know the atomic mass, just take them and add them to get molecular mass. So we understand how to find molecular mass. Now coming to the ions. Ions also having mass, and you should know that what is the formula unit mass for a compound which is created by ionic reaction, like sodium chloride. It is created because of sodium plus chlorine minus combination. Now how do you find the mass of sodium chloride? So that is called formula unit mass. It is applicable to ions. Say for example, Na plus Cl minus, the combination of Na plus Cl minus. You should know the Na plus mass and Cl minus mass to get the NaCl total mass. So it is nothing but 1 into 23 plus 1 into 35.5. It is equals to 58.5 U. You got it? How do you get it? See here, sodium 23, only one sodium ion, one chlorine ion. So 1 into chlorine is 35.5. So when you add them, you got 58.5 U. So same rule applied. But in ionic reaction, only difference is these are ions combination and here these are elements combinations. Okay. So in that way, you can find atomic mass, molecular mass and formula unit mass. try with this masses, finding atomic mass for some more elements. Now, coming to discuss about another beautiful topic, concept in this chapter, mole. You get surprised if I say that number of atoms in O2 is how much? 16 grams of oxygen equals to number of atoms in 18 grams of water. Yes, but you get a confusion here. How do you say that number of atoms in 16 grams of oxygen equal to number of atoms in 18 grams of water? Because 16 grams, 18 grams is more amount of mass, so you should have more number of atoms, but not like that. That is what the beauty of chemistry. If you take an element, if you take a compound, the element or the compound or any dissimilar elements combination compound, all they have same number of atoms according to chemistry. Oxygen which is O2, 2 atoms, so 16 grams of mass. Water which is H2O, the molecule, 16 plus 2, 18 grams of water, one molecule, but it is having 18 grams of mass. One molecule which is having 16 grams of mass, still they have the same number of atoms. So mole is defined as mole equal to mass which is equal to mass expressed. Which mass? Which is atomic mass. It may be molecular mass, it may be formula mass. So mole is a mass, but that mass equal to formula mass, molecular mass, atomic mass expressed in grams. So that is the definition of a mole, remember. So mole is a mass of any type which is expressed in grams. So if you see the previous example we discussed, O2 if you take, its atomic mass unit is 16U. It is atomic mass 16U, atomic mass. But if you express that in grams, so 16U becomes 16 grams. Then 16 grams of O2 is nothing but 1 mole. Suppose you have hydrogen, H2 molecule, and its atomic mass is 2U. Now, if I write it as 2 grams, the 2 grams has become 1 mole. If you take nitrogen, N7, 14 is the mass number, so 14U, which is the atomic mass unit. If I express in grams, 14G, it is nothing but 1 mole. So 1 mole is nothing but atomic mass, which is expressed in grams. And this 1 mole consists of few number of atoms. And that was investigated by a scientist called Avogadro. And he gave that number also. So here that 1 mole equal to number of atoms, number of molecules, and that is equal to 6.023 into 10 power of 23 atoms. So 1 mole of molecule consists of those number of atoms. 1 mole of, if I say 1 mole of substance, then it consists of those number of molecules. Okay, again I am repeating. 1 mole of molecule equal to those number of atoms, or 1 mole of substance equal to those number of molecules. So that is Avogadro number, and this Avogadro number represented with the symbol Na. N is nothing but number, A means Avogadro. So instead of writing the big number, you can simply Na. That means oxygen, which is 16 grams, consists of the same number of atoms. The nitrogen, which is 14 grams, which is also consists of same number of atoms. Hydrogen, which is 2 grams, which is also consists of same number of atoms. molecule which is water, 18 grams, it is also consists of same number of atoms. So here we are expressing the atomic mass unit in terms of grams. So when I circled here 16 grams, 14 grams, 18 grams, this is also called molar mass. So 14 grams, 16 grams are expressed with a new word called molar mass, because we are taking that mass for moles. That's what is also called molar mass. Molar mass.